get some of it. So on the worksheet booklet, precision measurement, there's a bunch of that goes on to the next page as well. And I'm going to come back to that later, not today. But just make sure you keep this with you because I'm going to assign from it as well. Okay, so limits to measurement. I'm gonna leave this for later. Converting within the metric system, going from meters to centimeters to millimeters. For today, we're gonna be fine without this. So we're just gonna skip that. So follow along. I'm gonna tell you the page number where we're gonna start, and that is page 81. Page 81. Okay. And if you have a calculator, from time to time, a lot of the numbers today are going to be fairly easy to do. So a lot of them you can just do in your head, but sometimes as you move along, it will get a bit more challenging, perhaps. We are also dealing with very, very small numbers. So I will tell you this here. When it says working with accuracy, I am thinking actually putting it at the front of the booklet. So I apologize, but I'm just going to tell you, if you go to the front here, just say do not round in this unit. This is the one unit where we do not round. Like we will use 3, 4 decimals or more, but we do not round in this unit. We want to be as accurate as possible. So right at the front somewhere where you don't forget about it. Do not round, okay? So that being said, if you have a highlighter or like something, a marker to underline, whatever you do to kind of emphasize things. In everyday life, people often use the words precise and accurate to mean the same thing, okay? But in math, right here in this unit, we're gonna discover the different meanings. We're gonna be very specific here, okay? So accuracy, how close the measured value is to the true value. So whatever you're looking at, that actually has a defined measure. It could be a pitcher of liquid, it could be a specific length, but there's a true value, and accuracy is how close you are to that value, okay? And here it is. Accuracy refers to the exactness of the measurement, right? Measured value must be close to the real value as possible. So I'm saying the same thing in various ways, right? You have to be as close as to the actual value as possible. If you measure something accurately, you should be able to repeat. You should be able to repeat the measurement and get the same value, right? That is important. That you should be able to repeat. So let me I made a little note to myself here. So add that after this, using your hand span, like using your hand span to measure would not be accurate. Why would using your hand span not be accurate? If I measure something with my hand span and then you come along and you measure with your hand span, yeah, you're going to get different answers, especially if you go against me, right? I have a ridiculous hand span compared to most people because I'm big, right? Somebody else comes along, it'll be smaller, right? So You cannot repeat it. I cannot say, hey, this is, 3 hand spans. What about you? Come and measure. I got 4. Like what? Like what's going on here? So it cannot be repeated. It's not a standard unit of measure, right? Would not be accurate because everyone's hand is different. I'm just going to leave it at that. Okay. Accuracy can be affected by improper or careless use of measuring device. So when I was during the pandemic, we were all home, and my son got this ridiculous assignment, like to find, like he had to measure everything in our house, and he hadn't used a measuring tape before. So we would measure the side of our house, and he was on that end, I was on this end, and the measuring tape was doing like the loop all the way to the bottom and then back up, right? Would that be accurate? It'd be terrible, right? So I told him, no, you have to pull, you have to make sure this is straight, right? So not using a measuring device properly will affect accuracy. I used to have a meter stick. I have a wooden one there, but I used to have an aluminum one. And my students, I don't know why, I guess these were grade 9s, but now I know why. But I had an aluminum one that would bend. And so when you looked at it, it was like all wavy like this after a while because they just like to bend it. Now you've affected the accuracy, not by much, but it's not accurate anymore because the measuring device has been tampered with, right? So you gotta kind of pay attention to that as well. I'm thinking of another example. I'm talking for a reason. I'm not just trying to waste time. If you're using a measuring cup to bake and you put milk in it, you put it in, you make sure now you put flour in it. What's going to happen? If you put milk first and then flour, is all of that flour going to make it into the bowl? Some of it's going to be stuck on the edges, right? And if you keep doing that, now that measuring device is not accurate anymore because you're not using it properly. You should be rinsing it, right? Or whatever, or using a different one. Anyways, so if it's damaged or improper use, I've given you many examples, then it's going to affect your accuracy. So here I'm going to add something. To be accurate, I'm going to go arrow up and down. That's why I'm putting this in the middle. To be accurate, you should be using a standard measuring device or unit. So if you say, hey, measure this in centimeters, we all know what a centimeter is. It should be the same on any measuring device. A centimeter is a centimeter. It's a standard unit. Okay? And that ensures, right, will be able to repeat, right? If you use a standard unit and you send this, like you text your friend on the other side of the globe, hey, I just measured this 172 centimeters. That person will be like, okay, got it, 172 centimeters, right? You're going to be able to repeat that. And the next one is the scale needs to be appropriate. Example, distance. Sorry, I'm gonna abbreviate this. Distance between cities. What would we use to measure distance between cities? Meters, centimeters, feet? what would we use? Kilometers, right? Or miles if you're in the US, right? We would use kilometers, right? So that would be an appropriate scale and an appropriate unit because we all know what a kilometer is, right? We know the exact distance. You're able to repeat it. So the standard device or unit, so measuring tape, ruler, meter stick, anything like that, and the scale has to be appropriate. You would not use a meter stick to measure the distance between two cities. It just wouldn't be a good one, right? It would take a long time, and you'd probably be off because you got to keep on like marking and then putting it over and then marking. Every time you do that, you'll be off a little bit, and it will just compound, right? You'll be off. Sorry, if somebody's still copying it, I'm going to leave it at the top there. Okay, so explain if the following measurements would give an accurate measure, and if the measuring device is appropriate, state why or why not. So, using the length of your forearm to measure the length of a picnic table, right? I will underline forearm and just say it would not be accurate. Right? Not a standard unit. I will just kind of just say, hey, this is not accurate. We're done. End of discussion. Right? Not accurate because of the format. We're not using a standard unit. Would the scale be appropriate? In terms of scale, is the scale appropriate with the using your forearm? Is it a small enough or an appropriate scale for a picnic table? Would you say? It's not bad. Like you're not saying I'm going to use my forearm to measure between two cities, right? You're not saying that. That would be ridiculous, right? But a picnic table, or I don't know, any smaller object, maybe even the length of this board, using your forearm is not bad. Okay, so scale is appropriate. Given the object, which is a table. So we're talking about are the units standard and the scale. We're talking about both things there. So I'll put like a bullet here and a bullet there. I'm going back to the two things we talked about up there. Length of your stride to mark off the soccer field, and stride, right, is a big, like your step, right? And so it's not accurate. And I'll just leave it at that. And the reason, well, maybe I'll say not a standard unit. You will not be able to repeat it, right? If you tell your friend on the other side of the soccer field, hey, it's 90 strides and I'll do 90 on my side, right? We won't end up in the same place, right? So you're going to be off. Okay. And the scale is appropriate. It's appropriate because we're talking about a field. We're not talking about between cities, or the distance from here to your home might not be inappropriate, right? Like if you have to walk, I don't know, 10 minutes, that's quite a distance. I would say that no longer is appropriate. Okay. Here we have using a meter stick. That's a check, right? Accurate. Because of this, I go arrow up, right? Using a standard unit, right? A meter stick is a meter, right? Using 1 meter at a time. Scale, do you think that's an appropriate scale? Between two cities, a meter stick? I would say You know how you have those signs that say, hey, 500 meters ahead, there's going to be a stop sign or something, or watch for that. That would be appropriate, but between two cities is no longer appropriate. Okay? Not appropriate. Should use kilometers. And I appreciate you participating, even if you get it wrong, because this is a new concept. So if you're like saying, yeah, it should be, and then it's not, don't worry about it. Okay, I get it. It's a different concept. Using a ruler marked in millimeters to measure the width of the book. So it's accurate. What about the scale? Would the scale be appropriate for the thickness of a book? Yeah, a thickness of a book in millimeters is very doable. Yeah, appropriate. Appropriate given the object measured. Okay, so it could be centimeters or millimeters. Both of them would be appropriate actually in this case. Inches, right? Quarter of an inch would be appropriate. Okay, so now you kind of wrap your head around what do we mean by accuracy? Accuracy means how true are you to the actual value? How close are you to the actual value? Can you repeat that? Right? Are you using the appropriate scale? So all those things come into play. So let's keep going. I will skip those 3 questions on page 82. We'll go straight to precision and uncertainty. That's where I want to get to. And after that, you're going to get some time to practice. So precision and uncertainty, right? Very important. And I will first focus on the small side notes here, right? Precision is the smallest, right? So precision is the smallest unit of measurement on the measuring device. That's very important. Like accuracy, precision is related to the exactness, right? But is determined by the limitations of the measuring instrument. Every measuring instrument has a limitation. Like the bathroom scale we step on, right, to see how heavy you are. Most of them are just like 0.1 of a kilogram or 0.1 of a pound, but it doesn't go into smaller units. It's limited to that, right? So if you want to measure like how heavy your pencil is on that, it's not going to work for you, right? It's limited, right? You got to use a smaller scale. For example, if your measuring device is marked off in centimeters, that is as precise as you can measure. Your answer will be to the nearest centimeter. A measurement made with a ruler marked in millimeters would be more precise, right, than the measurement made with a centimeter, because you're using a smaller, right, using a smaller increment, millimeters versus centimeters. Because of the limited precision of a measuring device, there's always some uncertainty. That's the other new word. Okay, so today we're going to learn about accuracy, precision, and uncertainty. Okay. For example, if you're measuring a box with a ruler marked in centimeters, and it is slightly less than 6 centimeters, you have to say that it is 6 centimeters long. You cannot give a more precise measure because of this, of the units of the measuring device. Okay, so I will highlight this. Uncertainty is the margin of error. Okay, if not stated, this is important, if not stated otherwise, uncertainty is half the precision. Very, very important. Very, very important. So I'll give you some examples here. Example, state the precision. Write this down. This is important. I'm adding this to make you understand this a little better. State the precision and uncertainty of the following. Double F like this is following. Try to learn those little tricks, because in university, if you go to university, your profs are not going to wait for you. So between, I go B/W following. Like, you try to find little tricks to speed things up. So let's say you have A, you have 6 feet, 5 inches. B, you have 185.19 grams. And C, you have 3.5 liters. So somebody wrote these measurements down, they measured, and they got the following. And you're asked to, just by looking at these numbers, what's my precision and what's the uncertainty? Every single one. What's the precision and what's the uncertainty? Precision, uncertainty. And you can only assume, because they're not giving you the device that has been used. How precise would this measurement be? The device that has been used is able to get it down to the smallest inch, right? That's the smallest unit. So your precision is 1 inch. I'm going to make sure that's a 1, right? Your precision here is 1 inch, right? Smallest increment, I will say. Smallest increment. You know that this device, whatever has been used, gets you to the closest inch. We're just assuming that. And what's the uncertainty again? It says here, uncertainty is half of the precision, right? Unless stated otherwise, but it doesn't say anything. So we'll just go 1 divided by 2, right? 1 inch divided by 2. Your uncertainty is 0.5 inches. Okay. So I'm going to block this off here, right, like that. Let me just move this a little over. Next, the precision here. So we look at this measurement, you focus on the smallest, right? This is the smallest increment right here. So what would the next one be? If it would be a little heavier, it would be 185.20, right? 185.21, 22. So it's going to go up by what? 0.01 of a gram. Because you focus on this, and then it tells you that that's how precise this is, to the smallest 0.01 of a gram. It's actually a pretty accurate, very precise instrument that you're using. The uncertainty is 0.01 of a gram divided by 2. And you will notice a pattern. Watch. 0.01 divided by 2. It's going to be 0.005. Right, so 0.005 of a gram. So you match the units that you had all along. So in this case, your precision is up to 0.01 of a gram. And uncertainty, remember, uncertainty is a margin of error. You could be off by this much on the higher end or lower end. You could be off on either end. So that's the assumed uncertainty. Let's cut it here. My precision here, I look at this measurement, I focus on that. It's 0.5, 3.5. So that means that this instrument gets me to the nearest 0.1 of a liter. 0.1, that is. And uncertainty is 0.1 liters divided by 2, which is, I will tell you already, 0.05. That's the pattern. You get an extra 0 and then you end up with a 5 in this case. Okay, so that's how we get our precision and our uncertainty just by looking at the measurement, because they don't show you the device that has been used, so that's all we have to go by. Remember this, you need your precision to get your uncertainty. I'll say it again, you need your precision, you need to figure this out before you get your uncertainty. Okay, otherwise you can't. So you got to start with precision, then get your uncertainty. Let's go, let's keep going. Page 83. It is often necessary to record how much uncertainty exists in a measurement. Here it is again. Unless otherwise stated, uncertainty is given as half of the precision. So I will do like a lowercase u is precision divided by 2, right? And I just made this one up right now, so I'm assuming that you will know what uncertainty is, and that P is precision in this unit, right? That's all we're doing. Like, I'm not going to give you another, like, uncertainty is always U, right? Precision is always P. I will skip some of that. Measurement uncertainty can be written as follows. I want you to box this in. If I ask you to write the measurement plus the uncertainty, plus or minus the uncertainty, I want you to write it like this. And I will tell you what that plus or minus stands for. Some of you are probably already, you know what that means, right? But the plus or the minus, right? What that is saying is that measurement can be over or under. That's what that is saying. It could be over or under the actual measurement. Have you ever put together something that you bought from a store? You had to put it together. Like, did you ever buy IKEA furniture? Sometimes it's just not 100%. Like, it's not like you gotta sometimes just twist it and try things, maybe tighten things a bit more, and then it's good. Reason being is that there's always a bit of uncertainty when they measure, right? Like, it can't always be 100%. Especially with woodwork, it's notorious for that. I will add something else here. Because of this measured value plus or minus, there's actually a min or a max. Okay. To get, can you write this down? To get the max, there is a high measurement and a low measurement possible. Okay. To get the max, we take the measured plus the uncertainty. To get the min, we take the measured value and we subtract the uncertainty. Obviously, those are going to be numbers, right? But those are an aside there. You can get a maximum value and a minimum value given this. It could be as big as this or as small as this. Okay, that's what this is saying. And that is from this that you're going to be able to get the max or the min. And here's an example, right? The length of a box, if it says 6 centimeters plus or minus 0.5 of a centimeter, right? It is saying that the length of the box could be 6 minus, right? This is 6 minus 0.5 that you got here. And this is 6 plus 0.5. So this is your min, and this is the max, right, that you got here. So you're saying that the box can actually be anywhere between those two measurements. Okay. One more thing, or I guess some examples here. State the precision and uncertainty of the following measurements, and I will add something to it if possible. So add this, if possible. Write the measurement plus or minus the uncertainty. Sorry, that was not very pretty. But it says measurement plus or minus the uncertainty. Just like we saw up there, right? I'll redo it here. Measurement plus or minus the uncertainty. Okay. So let's focus on this ruler here. First of all, we're going to focus on the precision, state the precision and uncertainty, and then we're going to do this next, okay? So if I could ask you, what would be the precision of this ruler? It's an actual device. What's the precision? Precision, I'll remind you of this, is the smallest increment. The smallest increment. If you look at that ruler, what's the smallest increment? What does it go up by? What's that? 0.1 centimeters? You are right. If that's what you said, then you're right. But there's another one. 1 millimeter. You're like, wait a minute, like 0.1 centimeter or 1 millimeter? The answer is both of you are correct. But I'm going to show you both of them. 1 millimeter, or write this down, 0.1 of a centimeter. I will say device goes up by this. Okay. The measuring device goes up by either 1 millimeter or 0.1 of a centimeter. Both are correct. Now we get our uncertainty. Our uncertainty is 1 millimeter divided by 2, which is 0.5 of a millimeter. Or you got to go 0.1 centimeters divided by 2, which is 0.05 of a centimeter. Okay. As long as you're consistent with your units, you will be correct either way. Not going to happen very often, by the way. So now we'll state the measurement. We'll say that this one, how long would you say this would be in millimeters? Because we're millimeters here. How long would you say this pencil would be? So I'm going to mark it'd be 62, right? 62 millimeters or 6.2 centimeters. Either one is fine. So I'll state it like this: 62 millimeters, and then there's the plus or the minus, right? You got to do both, plus or minus your uncertainty. Precision never makes it to this one. It's just the uncertainty. So now you've stated it. You actually went to the ruler and you got as close as possible, and then you say this could be off by 0.05 or 6.2 centimeters plus or minus. This is my uncertainty here. Always look at your measuring device for getting your precision. Okay? If there's a device, you go to it. Don't look at the actual measurement. Go look at the device. Okay? B. An odometer records distance traveled to the nearest kilometer. That tells you that precision is 1 kilometer. It's a dead giveaway. It says, hey, it's to the nearest kilometer. Go ahead. Uncertainty is 1/2, which is 0.5 of a kilometer. Sorry, you can't see that, can you? There. Precision and can we state measurement plus or minus uncertainty? Can we do that in this case? We have no idea what the distance actually is, right? So we can't do that. We'll just leave it. C. The outside temperature recorded is 12.5 degrees Celsius. Do we have a measuring device anywhere? Do they give us a picture of it? No. We have to go by the actual number. This is precise to the nearest 0.1, right? That you see 1 decimal there. So the precision is 0.1 degrees Celsius. Make sure you have your units there. Okay? Okay, look up one more time. I will add something here. This is where I get a little tricky sometimes. What would the precision have been? Maybe don't write this down because it's gonna throw you off. Sorry about that. What if I had said this? What if I had stated it like that? Most of us would want to drop that 0, right? But this is actually there for a reason. What's my precision in this case? It's not just 0.1, it's 0.01. That's how precise this is. So if I stated it like this, you make sure you have a 0.01, right? Like there should be 2 decimals here on your precision. So keep that in mind. Uncertainty, therefore, is 0.1 degrees Celsius divided by 2. And if you're not sure, don't guess. Use your calculator. But it's 0.05 degrees Celsius. And I'm going to state my measurement. 12.5 degrees Celsius plus or minus. I take that uncertainty and I insert it there. So this is if the question says, hey, I want you to state the measurement plus or minus its uncertainty. You go through these steps and then you plug in your uncertainty there. And make sure you have units, right? And D, I'm going to try to make that work here. D, Harpreet says that it took him 5.25 hours to drive from Vancouver to Kamloops, BC. What's my precision here? You look at the number because that's all you have, and it's 0.01. It's always going to be a 1, by the way. Don't go, some students go right down, oh, this one is 0.05. It's like, no, it always goes up by 1 unit. So that's hours. So uncertainty would be half of that. And if you're not sure, you grab your calculator and you divide that by 2. So you get 0.005 hours. So this we could say that it would take 5.25 hours plus or minus 0.005 of an hour. And this is where you want to kind of block this off maybe, right? To make sure this is 1 here, and this is 1 here. And so forth. Okay. I'm going to get you to work now because I've talked 40 minutes. That's a long time. So write this down, then I will assign you a few questions. I'm wondering if I... I'm going to get you to go to 84. And we'll do all of that. Whatever's on 84, I want you to try those. Notice that most of them just ask for precision, uncertainty, precision, uncertainty. So you need to figure that out just based on what it's giving you. Okay, so let's do 9 to 12. I know you're going to be done fairly quickly, so watch this. At the bottom of that, you're going to say go to page 2 in your workbook. Sorry, 3 and 4 I meant to say. Page 3 and 4 in the worksheets, right? Make sure you write this down because otherwise you're not going to remember that, right? Page 3 and 4 in the worksheet after doing this, okay?